So while Sumedh is doing his photo option, it is my pleasure to call upon the stage one of the tallest gemologists in the industry, Branko how do I pronounce your name, Branko? Deljanin. Deljanin. Well, I met Branko many years ago. He has always have shared his passion for synthetic diamonds, for the identification of treated diamonds using advanced technology, and he has been publishing books and articles on the subject, and also sharing his knowledge in practical workshops all around the world. He's president and head gemologist of the Canadian Gemological Laboratory, CGL, and also co-founder of the Mediterranean Gemological and Jewelry Conference since 2015. Ladies and gentlemen, Branko Deljanin. You see, he's really tall. Go ahead, the stage is yours.
Thank you, Rui. As Rui mentioned, we have a very high level of gemology in Canada. I don't know what happened to Portugal, but Rui is a great friend and, of course, a very knowledgeable person. And my speaker at my conferences, our conferences at Mediterranean countries. So I do respect him a lot. And thank you, ICA board, for inviting me for the only diamond lecture at this Congress. But it's very special because it's color diamonds. And it's Brazil. Most of you know me as a diamond person, and yes, I did a lot of research and books on diamonds, but I started in '95 in New York studying only gemstones. I love gemstones, color gemstones, and working in Gemident Research Department GA for 3 years. My first field trip after leaving GA was to go to Sri Lanka and study sapphires. And maybe some of you remember in Sydney 2001, I was presenting actually heat treatment of sapphires talk. So I do have a connection to color gemstones, of course. So let me tell you something about me and Brazil. I love Brazil, and exactly 25 years ago this month, I came with Helena Deljanin, expert on rough diamonds, to study rough diamonds in one river in Coromandel. That changed my life because I fall in love in Brazil, now a 5th time, and I fall in love with Helena. So we keep coming back to Brazil. We love it. People are great. We bring our kids here. So this was my first project on color diamonds. As you can see, in my laboratory in Canadian Gemlab in Vancouver, we study color diamonds and do certification. They're very popular still for concentrating wealth. People still believe that, and it is value in color diamonds. And we know that white diamonds are losing colorless diamonds value last few years, but color diamonds are holding and increasing in value actually. And as you can see, I do also other gems, not only diamonds. And very important for this topic and this conference, because a lot of talks about tracking the diamonds, gemstones, sustainability. I will use only twice this word today because it's used very often. And I do, with my team, track Canadian diamonds from different mines. We do lasering and branding of them in Vancouver, and Argyle pinks. In last 2.5 years, I did 2 big projects with the Royal Mint of Canada, who are using pink diamonds from Argyle, very small stones, 1, 2, 3, 5 points, but they're still expensive per carat. Talking about 1 to 3 millimeters in size, and putting in the coins and selling as a special collectibles for $5,000 US. So they're valuable even if they're small, talking about Argyle pink diamonds. But it has to be provenance report proving they're Argyle. This is what I will explain later, what happened in our research. I'm very proud to, I did research with the GRS, Gem Research Swiss Lab. It's one of the leading gem laboratories in country of origin of gemstones. And between 2014 and 19, we actually, they invested in a collection of pink diamonds from Argyle, Australia, Brazil, Russia, South Africa, Canada, and I think Venezuela, yes. And we did this project of provenance of pink diamonds, what is the topic of today's lecture, how we can separate them. So this is the outline. I will touch on other colors as well, but not so much in the lecture. I'm very grateful to Alexandris Ioannis, who is the commission chair of ICA, and Cynthia to put an article here on page 23. You can read more about other colors in Brazil. I talk about pink and red today, but of course they have many other colors. And I will just show you these nice P charts here in the article and tell you why it's important to talk about color diamonds in Brazil. Maybe you don't know, and I was surprised as well when I found these statistics from a very good Brazilian researcher, geologist, Carfunkel, and Don Hauer, who is an American geologist. Quarter of all red diamonds in the world, and they're the rarest color diamonds, are found in Brazil, 25%. Do you know how many diamonds over 324 carats in the world are found in Brazil? Talking about largest diamonds. Any clue? Almost half of them. So 75%, okay, not almost, but 70, so 3/4. It's amazing. So this is a very important country for important colored diamonds and white diamonds as well, if they're big. Lena is the expert. She will tell you more why Brazil exactly has large diamonds more than other countries. I will talk about history, historical sources, of course, Brazilian diamonds, Argyle diamonds, and other countries, Canada, Russia, Venezuela, that we study, and what we can do as a gemologist or regular dealers using just standard instruments, talking about loupe, microscope, simple UV lamp. I'm trying to explain this in simple terms because you're not all gemologists, but I do excuse, but I will use some spectra. Focus, please. You can understand this is not so complicated. I will try to be as simple as possible. And focus on fluorescence, something easy to see, strain in diamonds or stress, what cutters would call it, and what other systems on the market are using to grade color diamonds. Of course, GA is the most recognized as the oldest and most biggest laboratory in the world, but there is a Argyle system of grading color diamonds, and my laboratory, small, but tall and big with me, are trying to put different system in GRS, little bit modified system. You will see differences. And what instruments we use, this is not enough time to cover today, to separate natural, synthetic, very important, and treated pink diamonds just using simple instruments today, because we're not a gemological conference. And in practical conference, I do explain this with instruments as well. And cutting and recutting of pink red diamonds is very important. Why? Because to get from fancy intense to fancy red is big price difference, or fancy intense to fancy vivid as well. Okay, and value of Argyle pink diamonds. I hope you appreciate some color today. And you can see one in the middle, heart shape, has flashes of red. This is your fancy red diamond. Pink red group of diamonds is not pure pink, pure red. They are a combination of colors. We have a major color. You can see top left, it's more pink, but has a maybe purplish modifier. On the top right is pinkish brown diamonds, more brown than pink. On the bottom right, it's more purple than pink, probably from Russia, Siberia, this kind of stones coming a lot. On the left, you see more orangey pink. So, of course, more brown, less value. More pink or red, the higher value. And very important to grade properly color diamonds. Okay, this is a big chart. I won't repeat every word. Hopefully you can read fast. I like to give you a lot of information in a short time. This is me, sometimes too much. But anyway, I will try to outline the most important countries. And those underlined are those we study. Brazil, South Africa, Venezuela, Congo, Russia, Australia, of course, and Canada. But other sources are historically Indonesia. I was there to teach, but unfortunately didn't go to Borneo. They have some pinkish brown diamonds. India is a very important source historically, and large diamonds. And in museums, you can see Golconda diamonds. I've seen them in museums, but I couldn't study them because very difficult to get them. Brazil, of course, was major source after India, was 2 centuries major source. Then India was 18th and 19th century major source of diamonds before they discovered South Africa, of course, end of 19th century. Venezuela is interesting because at the borderline of Venezuela and Brazil, they found pink diamonds. And at the end of the lecture, we'll see one very important red diamond now in collection in Smithsonian. That origin is says Venezuela or Brazil. They didn't study, I guess, not very well, but maybe at all, gemologically. But why it's important? Because sometimes these stones from Venezuela are passed with the Brazilian Kimberley certificate and exported, so it's difficult to tell geographically if they are from Venezuela or Brazil. Tanzania has important stones as well. Congo and this part of the world, Africa, of course, Angola, Botswana, Lesotho, last 10 years. I didn't study all of them, but Australia is the major source since 1987-8. 90% of world production of all pink diamonds came from one mine, Argyle, Australia. Unfortunately, closed in 2020, but still diamonds are out without provenance, so it's important to test them. I'm in Canada since 2002, and we have some pinkish purple diamonds, not so many, and we'll talk about this. So just one picture from a dealer from Las Vegas. His wife is from Indonesia. They went to the mine. As you can see, they're mostly brown and yellow, but alluvial diamonds, very old source. Still active sporadically. It's Dutch colony, so they used to, of course, export them via Dutch agencies, same as India. Of course, you know that Tavernier was the first person, French explorer, who went to India in 16th century, and it was a special route of bringing these diamonds to Europe. One of the biggest pink diamonds ever on the record is 186 carat Darya Nur, hopefully I pronounced right, Ocean of Light, now in Iran's Imperial Collection in Tehran. And one of the biggest pink diamonds sold, you can see it, 34 65 carat Princess, is sold at more than $1 million per carat for 39 million at 2013 auction. So as you can see, India has these big diamonds. And the reason why India and Brazil has larger diamonds than other countries is because they're type 2A, what is a type of diamond with a very little or almost no nitrogen present, and they can grow very large crystals. Just simplify as that. In October last year, I went to India, second time. I was first time 1998 when I went to Sri Lanka and India. This time was to teach my program to separate synthetic diamonds from natural in Mumbai, Surat, and Hyderabad. But when I saw Hyderabad is only, whatever on the map, looks like 200-300 kilometers from Krishna River, I got the idea. I told my Elena, I need to go to Krishna River because this is the first source of diamonds. I didn't know how big is a challenge, but I'm a very stubborn Serbian guy. So 12 hours to Hong Kong, 8 hours to Mumbai, 1.5 hours from Mumbai to Hyderabad, rest, did some teaching. And then the last day before I came back to Canada, my very nice good friend, Indian laboratory, Prasad, told me, Branko, we need to wake up tomorrow, 5 o'clock in the morning. So why? Because you'll see, it's a road. So 3 hours on a relatively good highway. Then you go to this in the middle, this kind of road that you really bumpy, lot of holes, goats and all kind of animals coming. 1 hour on this road. At the end, no more, we stopped there, have a little break, water. He said, no more cars can go anymore. So last 1 hour, you see on the left, me, actually De Beers, head of De Beers in India was with us, Prasad, his father, and one guy who is in front of me. He's a Jewish Indian. This is interesting. He is the kind of geologist, jeweler, gemologist, whatever. He drive me on the dirty road, rocks, holes. I even walk some to come to this river, famous where all big diamonds, like you can see on the right, Hope diamond, all these big diamonds that you saw before coming from. For me, it was wish to be there, and of course, I bought some rough diamonds. Hopefully, they're from this river. I will come back there in a few years because it was too big river to do any digging, and it's allowed basically to do small diggings, and we still see holes from local people looking for diamonds, even now. It's not a mine anymore, but still you can find diamonds, believe it or not. Okay, let's go back to Brazil. This is a very important map given by me to now late Don Hoover, American geologist who spent his lifetime, can you imagine lifetime, 40 years just spending in Brazil looking for pink red diamond source, where they're coming from. And you can see on the map, I hope you can see on the top left, there is some points from one area. And on the top left, you see 700 something, sorry, I cannot see very well, 720, it's in your article. Vargas diamond, one of the biggest diamonds from Brazil, colorless, but some important pink and red diamonds coming from these rivers. And I just want to point you down to the one triangular modified brilliant you can see on the second from the bottom, Mosef red, comes from one of these rivers. And actually, I can tell you exactly the name. And me and Elena were there in 2000, just basically a few years before that, boy found, they brought us to this river. It's a small river. So this is the boy, Elena, I remember, who dived here and brought 2.5 grams of pebble to his father. He said, Papa, look at this is a red pebble. And Papa was smart enough to really observe the pebble and bring to the jeweler to Belo Horizonte, who had more experience, and he said, this is probably diamond. So William Goldberg, famous Jewish cutter from New York, bought it, who knows for how little or how much, and cut it in New York beginning of 90s. And that was just the right place, the right time. Usually I'm a lucky guy, as you can see, being here. And I was in 95, 96, 97 in GA, and we tested and certified at that time the biggest red diamond ever tested by any laboratory. I was in GA in New York, Tom Moses was my supervisor, and I was handling for a few minutes 511 carat fancy red diamond. At that time was sold at 1.6 million per carat, and now estimated for over 20 millions. So this is the price of red diamonds. This is, I don't know if it's still biggest, probably not, but one of the biggest. You can see in the middle now, biggest picture of this 511 carat. I like to say 1 gram of carbon that nature, by miracle of nature, make it to be fancy red. Certain pressure and temperatures play with this stone to be exactly the form, not too much. If it's too much, it will be colorless. If it's too much, to be brown. If it's too little, colorless, in between. You can see on the top left is round 0.95 Hancock red. Why it's important? Because it's historical stone. It's one of the first stones sold almost $950,000 per carat, almost $1 million at Christie's in 1987. That was big revolution because nobody was selling colored diamonds so expensive. They're buying them very cheap, brown, pink, green, blue. But they're not white. They're kind of off color. But that changed the history. And then opened the mine in the same year or year after in Argyle. Lot of smaller pink diamonds on the market. So jewelers can now use supplies of pink diamonds, and they're not cheap anymore. You can see very nice vivid purple pink, also from Brazil, from collection of Don Hoover. So you can read more about his research in this article. So we did study, of course, there are many different ways to study pink diamonds. When we came first time, this is me when I was young, 25 years ago, one of these river that we were sent by New York dealer, who actually Lebanese owner, to estimate what is the potential of this river for the diamonds. They bought a property. So me and Elena spent 10 to 15 days there every day on the dirty track, 2-3 hours in the bush. Like Brian probably knows what you're talking about, roads in Brazil. But we were every day spending all day with the locals, looking for diamonds. And of course, at that time, first time we bought some stones for research in Belo Horizonte, and then later in Hong Kong, this is stones on the bottom, very supportive, the French dealer Francis Herrera from Four Lovers, Hong Kong, gave us some stones to study. It's important to have dealers like that because he was smart enough in 80s, 90s to be on the first Argyle site holder. Why it's important? Because they were still cheap at that time. He is now a millionaire, slowly selling over the last 20, 30 years. He has office in Hong Kong, big house in Brisbane, I was in his house, hotels in France, whatever, daughters living, because of Argyle pink diamonds. He was just the right time, the right place to buy good stones. These stones, Brazil, as you can see, what we studied, they do not fluoresce. When you put on the long UV, short UV light, and Elena has it under the table, a lot of our instruments to show you. It's not practical workshop, but who wants to see how it looks instruments, long UV, short UV, gemologist using it, do not fluoresce. Okay, so this is Elena, hopefully you can see her, with the local miners in 2000, one of these rivers. All day long, basically we went with the excavator to dig the holes, put it in these sorters in the river, like more or less like a gold. Why it's important? Diamonds are heavy relatively, specific gravity 353. So some indicator minerals like picro, ilmenite will go together with the diamond, and lighter minerals like quartz, pebbles will stay on the top. When you shake like gold your bucket, you basically do upside down, and you can see with these black minerals, usually, hopefully, we found few diamonds per day, not like every hour we find a diamond. And so we did our report. I don't know if end up to be any more activity in this river. We didn't follow up, but we did our job and report on how many diamonds we found in this property at that time 25 years ago. And then we went, of course, to Diamantina. You'll see now in other locations. They also have another way to mine diamond by washing down the conglomerates. You can see on the left, it's a huge kind of, we can call it dike. They're washing down and then collecting these and looking for diamonds. You can see in the middle, Elena, with one of these holes that they were digging, and they're showing layers of this close to river where we're looking for diamonds. The other way to do it is also on big rivers, use these big dredgers. This is one just on the side because it's out of season, it's a dry area. So they also use this not only in Brazil, in Africa, to find diamonds and other minerals in the rivers. Okay, I want to thank Daniel Berenger, who is here with us, who gave me these photos just for this article and for this presentation, because updated what is now, how it looks, crystals lately, what he collects and have access. This is one stone on the top. You can see vivid pink diamond from Coromandel, what is the area of western Minas Gerais. This triangular is very famous for finding all important pink diamonds. In this case, this stone did fluoresce blue. So not all diamonds from Brazil do not fluoresce. But this one in the middle, it's quite big actually. You can see 33.50, fancy light pink, from this triangular or miniero, what is a triangular of mining in Minas Gerais. I guarantee, I know, Daniel, if you try it, but this stone should not fluoresce based on morphology or shape. It looks like a type 2A diamond. They do not fluoresce. And same on the bottom right, you can see one big brown diamond, very unusual shape. This is probably by shape. We can know it is a type 2 without a nitrogen or very small amount, less than 5 parts per million. On the top right is more fancy tense pink. This is your type 1 diamond. So basically, hopefully we come back to Brazil to teach more. Elena and me like to teach. We're teaching actually in Rio before conference. We're teaching tomorrow and Saturday on synthetic and treatments, but we would like to teach about rough. This is something that this industry needs, how to sort diamonds by shapes, by quality, and of course, the end is valuation of rough diamonds. So again, sorry, I cannot talk about Brazil all day. I would like. I have so much information, but it's in this article. I need to move to other countries that are important for pink or red diamonds. South Africa is not, right now, used to be number 1. Now it's number 4 by value of all diamonds. And some mines, like Lace Mine, has pinks. And this is one of the biggest pinks found in South Africa. 5960, called Pink Star, certified by GIA and Goblin, as fancy vivid. It doesn't look so vivid on the picture, but this is what is the grade. And you can see in the middle, William Berry, GRS gemologist from Lucerne, going to Geneva, and he looked at the stones, and fluorescence was a kind of weak, I can say weak medium blue. So they could have some fluorescence, even probably type 2A diamond, not because they're big. Sold at 73 million eventually to the Troy Tai Fook, big jewelry chain from Hong Kong. You're familiar, they're the biggest in China. So Russia is, of course, always number one or number two producer of diamonds by value. They started in the 1950s after the Second World War. They also started to produce laboratory-grown diamonds, synthetic diamonds, same time in the 60s. Diamond is very, very important material. It's such a special material. Nobody studied more any gemstone or any material than diamonds. And so this is the stones. We acquire 100 stones via our friends at Moscow State University. We just buy them and study them. These stones do not fluoresce. They're more purple than pink. You can see a picture on the right. And very interesting, what you can do with a simple loupe or microscope, if you're not good with loupe, you can find surface growth lines that goes to the surface of the stone called surface graining. And all colors is in this graining. Purple color is in there. So if you look from the side of the stone, from profile, you can see colorless and purple graining. Colorless. So this is your evidence without going to spectroscopy or laboratory to know you're dealing with the probably natural color purple diamond. If it's coated pink, what is another problem, we studied them and discovered it in 2004-5, there will be even color, no graining, because they are different type of stones as a starting material. Okay. So what is also important about Russia is not only Siberia, there's another source. It's in northern Russia, close to Finland, there is a mine called Arkhangelsk. And I was invited by Alrosa to special viewing for dealers and researchers to September 2018 in Hong Kong, just to look at a big collection of coal diamonds from Russia. It was amazing. And we had a chance to see this 2785 carat called Nijinsky diamond, estimated at that time 37 million. I'm not sure if it's sold or not, but this is your one of the diamonds. You can see here, this diamond has medium blue fluorescence under long UV light and faint blue, similar to Argyle pink. So fluorescence is not enough to separate if it's Russian or Argyle or Venezuela. If it's none, cannot be Argyle. But if it's medium blue or strong blue, could be other source. Just to give you some introduction to provenance of pink diamonds. So this is about that. And Canada is not important source of pink diamonds, because I'm from Canada. I have to show you what we have. As you can see, this is published in also in AGTA Prism magazine. Faint pink, so it's not really fancy. Faint pink is just, a tint of pink, not even fancy light. On the middle is more like a brownish pink, also not very expensive stone, but over carat. The biggest one I ever seen was 1275 light pink from Victor Mine in Ontario. Unfortunately, it's closed. This is a problem with Canadian diamond industry and generally natural diamond industry in many countries. They're closing old mines because they're running out of diamonds, sometimes because of this situation with the white diamonds. They closed Renard diamond mine in Quebec. My wife was working for indirectly for Stornoway Diamond, who discovered this mine, famous diamond queen of Canada. Ara Thomas was owner. Now they closed the mine because the price is so low they cannot operate. So this is a problem with natural diamonds. Unfortunately, we hope to change that. We are working on some documentary series of 5 to make a movie on 5 continents promoting natural diamonds, also covering laboratory grown, because it's amazing that men could make the diamond. I'm impressed. I studied them, but we want to give a true story for the young generation to do proper choice. Hopefully it's their choice, but not misleading, sustainable politics of laboratory grown diamond. They are clean, they are conflict-free and all kinds of things they're putting in that, but a lot of this information is really not correct, what we think. Anyway, this is spectroscopy. Oh, okay, I have one spectra, but anyway, what does it mean, this spectra? I'll just explain you in 10 seconds. This big peak in the middle, just tell you this is a diamond. This is how every diamond has this peak, talking about this big, huge, like a mountain. On the right, even higher peak, this says A and B. This is your nitrogen. In case of Canadian diamonds, there's a lot of nitrogen in the diamonds, same as Russian. So you can see Russia and Canada are connected geographically. They are next to each other, really, but used to be Alaska, was part of Russia before. So it used to be same kind of similar geology. We got 10 carat of rough diamonds to study, and from Canada, as you can see, no fluorescence. People wonder why these diamonds don't fluoresce. I can explain it very simple. Like people, many of here gem dealers here, and our gemologists, like Wim and other people knows, when sapphire has a lot of iron, will suppress fluorescence of sapphire. It will no fluorescence, like a basaltic rich iron stones I was in mining in Australia or Thailand. When sapphire has a lot of chromium, will give a reddish or red fluorescence. This A aggregation, which is 2 nitrogen atoms, suppress fluorescence, and it has a lot. So basically, even diamond has nitrogen does not fluoresce, and this is the case of Canadian and Russian diamonds, very consistent with that, if it's from Siberia, Russia. And now going to major important source of pink diamonds. I was there first time in 2001. I fly from Sydney to Perth just to meet Rio Tinto and to look. I met John Chapman, at that time manager and advisor for the company. And since then, we did a lot of research on pink diamonds because I studied treatments of pink diamonds a lot, coated, multi-step treated, and I was very proud that Rio Tinto gave me a research grant in 2007 to study pink diamonds, natural, treated, synthetic, and how to separate them relatively easy. This is my project with my team international. And then we came back with Dr. Peretti, head of GRS laboratory in 2014. That time, open mine was closed. We just have a picture. We went underground. This is lamproite rock. I'm also a geologist. They're a little bit different, lighter and younger rocks than kimberlites from Canada, Russia, and other sources. And interesting enough to know that people think every mine is gem quality. No. 70% of these diamonds are near gem quality. A lot of them, industrial diamonds, is less than 0.10%, has pink coloration and represents 10% of the value. So 0.1% of the diamond by volume has 10% of the value. You can see how it's important are these pink diamonds. I'm amazed with this picture. I was allowed to make it, but I was impressed how many diamonds they can make in one day. It looks like a lot of diamonds. Yes, it is. 14 kilograms of diamonds they can make in one day. It's amazing, you know. But this is the largest single mine in all history of diamond mining in the world. And you can imagine, but not all of them are gem quality. So to find good quality diamonds, especially pink, it's still rare. But yes, they can make a lot of diamonds. Majority of them less than 10 points. So very small diamonds, they cut in India. The largest one was 4260 and is in a museum in Melbourne. A lot of shapes, different. Elena will talk about this more, but I'm not expert on rough diamonds. But anyway, usually they are dodecahedral and type 1 diamond. You can see the shape on the right and a resulting color, a very nice pink, purple, and purplish pink diamonds. So underground from 2013, we went down, make some pictures, and it's an amazing operation. But at some point also becoming too expensive to go down, so they stopped it in 2020, and now they're on the market, still selling, but I guess because of that, plus good marketing of Rio Tinto, plus sustainability, they have a tracking how they're doing mining, and they, of course, will preserve or close this hole after and make sure everything is correct. So this is what we can see. I studied these stones 2007-8. I published a paper in diamond-related materials. One of them very, more than 5,000 people read this paper online, ResearchGate. Anyway, this is your diamonds I was studying, and you can see on the right how it looks, pink graining. When you put this stone under what we called a small polariscope, under cross-polarized filters, they have a strain or stress. You can see on the right, mixture of blue and other colors. This is your type 1 diamond, natural diamond. Just using simple instrument, we can tell this is natural diamond, because synthetic will look different, you'll see later. Based on only one test, fluorescence, I know this is natural diamond, cannot be synthetic, cannot be treated. They fluoresce medium to strong blue and weak under short UV light. Don't be confused on some report, GA or other labs, sometimes they call it weak or medium. All depends how far is your UV lamp from the source. I'm using jewelry inspector, peel inspector, more stronger. I want to see a reaction because for me it's important gemologically this information, and then grading wise is not critical if it's medium or strong. It doesn't influence the value. This is my group. I went every 2 years to Australia to teach in Perth. We study 1 day colorless diamonds, treatments and synthetic, and 2nd day color diamonds, natural and treated, and this is a 2-day program. On the right is one of the tiara with the 175 pink diamonds. What do you notice? All of them on the right fluoresce blue. It means they're all Argyle, and they certify each of them, they have laser inscription. Argyle is doing it for 20 years approximately, but for 20 years before, no lasering, so a lot of stones on the market still not laser with this famous A broken by Argyle. So that's why we use these instruments. This is a custom-made instrument made by one good friend and good gemologist and instrument maker, Thomas Henschwagen from GGTL laboratory. He made 3 of these for 3 laboratories of GRS, and I was in Hong Kong and Bangkok studying this with the 2 photoluminescence laser 405532 and visible spectroscopy. We cooled down at liquid nitrogen temperature minus 198 degrees, whatever, and we measured the spectra. This is a key test to separate sources, not only fluorescence and pattern. Okay, another spectra, but if you remember, one from Russia was huge A and B peak. Here is a little bit smaller, you can see on the right, and guess what? It's very consistent. This B peak in 1170 something, it's always bigger than peak on 1282. And this is what I found in 2008 and published it as a fingerprint of Argyle diamonds, one of the fingerprints, not the only one, because it could be such a stone from Brazil, for example, but more rare, this is more Argyle fingerprint. And visible spectra on the bottom, you can see a famous 550 band, we call it pink band. Why pink band? Because this is exactly in green and yellow part of the visible spectra. On the bottom you see blue, violet to red, this is visible spectra, and this part of green, yellow, diamond absorb light, that's why you have transmission in blue and pink area, making this stone purplish pink or other variety of pinks. I want to thank again ICA Gazette and ICA for publishing an article in 2015 by me and GRS people. You can find it on the website of gemconference.com. Our first conference, we talk about this. So this is just a summary for you to take away from you that if it's medium to strong blue fluorescence is indication of Argyle, but could be also Brazil, Congo, Russia, Venezuela, not all Russia, Western Russia, more Northern Russia. If it's in the middle, tatami pattern, no fluorescence except Golconda could be weak to medium orange, it's not Argyle. So this is how we very briefly separate these categories using standard test. Of course, key is this advanced fingerprinting using visible, infrared, and advanced spectroscopy. Just 4 slides on this because it's important for you to know potential of these techniques. Guess what? There is no other color, I think gemstones as well, than pink and red that do all kinds of treatments. So this is 3 stones, no way you can separate with a loop. Could be natural color, natural diamond. Could be natural color coated. Sorry, natural diamond coated. Could be brown color coated. Could be fracture filled diamond. I've seen so much purple flashes make purple color add into diamond. Could be irradiated and heated diamond. Could be just HPHT treated, usually not so intense. Could be synthetic HPHT, synthetic CVD, or could be combination, multi-step treated. I study all of them, and that's why I got this grant. And this is why simple way to do it, to put on the cross-polarized filters on the left, we turn the stone transparent, no stress. Baby-born, happy diamond, made in laboratory in China, India, Russia, Israel, maybe US, because they're still growing, but very rare HPHT, mostly CVD. On the right, stone grown in China, on the market by a PDC, the Hong Kong show and Bangkok without disclosure, we discovered it is pink synthetic, has this columnar pattern because carbon vapor deposition is growing in the layers. Of course, much more in the books, 2004 first edition, 2007 second. famous gemologist from Portugal, Rui, translated in Portuguese. Hopefully it is a good job because nobody complained in the last 15 years. So sold 500 copies in Brazil, and yesterday IBGM, thank you, SEO, got another 50 copies. So who wants this in Portuguese? Please talk to IBGM. I have English copies, and Elena has some other books. Who wants to read more, of course, on diamonds, I can show you. These stones has flakes and amorphous carbon. So this is something you can see in these kind of stones. This is my simple synthetic kit, very inexpensive, $600, that contain UV lamp, cross-porous filters, and 2 books. One on fluorescence of diamond, one on cross-porous filters, or if you're a gem dealer, I give you this book on pink or red gemstones or green. I have all kinds of books covering not only diamonds. So this is interesting for you if you want to do practical gemology. Okay, this is the result of that. Top right, natural diamond, natural color. Bottom, irradiated and heated, color changed to yellowish orange. Peach color, multi-step treated on the bottom left. Top left, at that time, 2008, no CVD pinks, only HPHT, orange. On the right, you can see the same thing in this booklet. Elena, you can show it, fluorescence of diamond, yellow booklet. How you can separate this based on just on fluorescence. You can see on the bottom how it's strong orange fluorescence synthetic. In the medium, it's like long UV is still stronger, but color is kind of peach. This is your treated stones. And no fluorescence does not mean anything. You have to check more for the other test, but in this case, it's Brazilian diamond. Just one more spectra to show you, and we practice this in Rio. It's not so complicated. I know American gemologists are afraid of little spectroscope, but with a little training of 5 to 10 minutes with me, you can find this black line in a pink diamond, proving this is your treated pink diamond at 637 black line. It's as simple as that. So you don't need to send all pink diamond stones to all laboratories. I'm doing job against me, but it's true. I'm showing you some simple tests. Last group of slides is about how we describe pink diamonds and grade. Very good book of Stephen Hofer, expensive book, $500, but I would recommend. He's describing in general terms like rose color, bubble gum. Very good. Dealers talk to each other. I have bubble gum pink diamond. It means it's intense purple pink, you know. Okay, this is your description. Not so accurate, but one way. Another way to send to GA laboratory, HRD. This is a tender 2000, but should be some differences. Same stone graded fancy deep pink, I1 by GA, fancy intense brownish pink by HRD. So you can see, judge by yourself. On the right is fancy vivid, and HRD has fancy intense. HRD doesn't have fancy vivid category. GA added, I don't know exactly when, but when I was there, it was still there. It was there, 1995. So this is how GA and HRD would grade it. What we notice the problems. On the left, both stones grade fancy pink by GIA. You can see a big difference in color. I match it with the Mansell color chips. On the right, fancy intense, one very nice fancy intense, one very much close to fancy, because it's a range. It's not one point in a color space. So what we decided to study more than 100 stones from a dealer in Hong Kong and develop these master sets that has 3 fancy, fancy plus, fancy plus plus, fancy intense, also 3 categories, and 2, and be more accurate, hopefully. We call it GRS, CGL grade system. We issue this on fancy diamond provenance report. We create masters sitting in Vancouver and Hong Kong. This is one of the best stones I've seen in Vancouver, fancy purple red, VS2. Purple red is more rare than just red, and this is interesting. And we use masters and Mansell chips to assign the color grade. It's always good to have 2 because it's not possible to have masters in all possible categories, and GA also knows that. I'm amazed with technology of cutting and visiting this Lemon Lexus technology in India was an eye-opener. They have such a good technology based on Octonus, Russian mathematician, physicist, now live in Finland. So basically, they can predict the color of diamond as rough by studying spectroscopy, and then they can recut it, cut it to nice pink or other color. A very amazing system, and guest in my conferences. So this is a high technology applied to improve color of diamond. Why it's important? Can you imagine difference in value? 171 fancy intense bought Argyle tender, big stone, recut, 168 fancy vivid, lost only 3 points, but price went up a lot. And why I'm doing this provenance of pink diamonds? One more reason, because trade wants to know. You go to Library's website, there is a pink category, there is Argyle pink. 15, 20, 30% more, depends on the stone. So, and these stones goes increased in value 30-fold in over, 30, not times, 30 times. It's amazing. So to summarize, what is a rosy future? I mean, it is or not. Australia and Canada are following the rules of tracking their diamonds, paperwork. We can always go and find where they're coming from. That's why people, consumers, will pay a little premium, even Canadian white, but definitely for Argyle pinks. And there is some problems from Santa Elena, Venezuela. Is it Venezuelan or Brazilian? So it's important to study these stones where they're coming from, geologically, gemologically. This stone sold at Hong Kong show for 4 million, but no origins, just pink, red diamonds. So it's important. So we think maybe in the future, people will ask for a country of origin of important diamonds. This is our report. You can see fancy purplish pink, very close to intense, but not. And science of gemology is evolving. I'm very happy to be part of it. I'm cooperating with all laboratories except 2 big ones, but this is how it is. And we would like to educate, train people like you and general public. This is, for example, Winston Red, nice article coming up in Gems of Gemology. Pay attention to 2 things. It is fancy red, 5th largest in the world. Origin Brazil or Venezuela. So it's not known, but I think it's important. You could be seen in Smithsonian who goes there. And to finalize, this is not just 4 years of study with one laboratory. This is 20 years of different collaborations. And the latest one article is here. I encourage you to stop by and get my business card. I can send you any of these articles if you want to study more. And just for those who want to really to immerse themselves in education, we teach FGA program with my wife Elena in Vancouver. You can become, in 3 weeks intense, I think I'm the only one in North America doing this, become, I think, different level than GG, a little bit different perspective. I think better because I'm GG and FGA, to become FGA. We teach online as well with a lot of good people like Dr. Laurie Kiefert on origins and great people on diamonds. So I do encourage you to see some lectures are also for free. You can listen to my lectures on detecting set diamonds without charge. Some of them, if you want certificate, we do charge. Last thing, Roy, I know his time is up. I invite everybody to Montana who wants to, especially Americans or those who, I do a special conference mid of June. We're going to Safari Mines, Yogo, Missouri Creek, and Potentate with 3 best gemologist guides. And Dubai 2026, just a warning, say your date. I'm coming to Dubai to international conference with the pearl diving in Bahrain and workshop on turquoise, diamonds, and amber. Thank you for listening. It was intense talk, a little bit longer. Thank you, Rui, for organizing to be longer. And for patience and any questions, I'm here to answer.
Thank you very much. Thank you. Thank you indeed. Actually, I'm a gemologist, so next Congress, if you have a gemology topic, come to me and I will give you more time because I think, but I'm biased. We do have some time for questions, but before that, you mentioned Golconda,
Yes.
And we have a Golconda here in Brazil, near Minas Gerais. Yeah. It's known for the pegmatites, but originally might have been named Golconda precisely because of the Indian origin. And I have one question before we have one from the floor, but I will take the privilege of being the MC to ask one myself. Even regarding Golconda, you mentioned that some of those Brazilian pinks are type 2A. So sometimes they are known in the trend as Golconda pinks because they have the nitrogen vacancy defects. Can you comment on that?
Yes, some labs, not mine, would issue a Golconda letter. It's mean, they will say, but when it's a polished cut gemstone, an antique shape, they will put a comment that this is a type 2A diamond with low nitrogen and some provenance, old cut, and could be characteristics of Golconda type.
Yes.
So this is very wide description. So basically, could be from Golconda, India, could be from Golconda, Brazil, because yes, Golconda. What I studied, I have a few stones when I was in GA and before, with the type 2 diamond with the orange fluorescence. This envy center is also created naturally. That could be created artificially. They become strong orange and obviously treated. Could be created naturally. Then it's a very small, less amount of orange. And long UV fluorescence is stronger than short UV. Very important because this is your good sign. This is natural color, not treated.
That was the comment I was looking for. Yes.
Hi, Branko. My question is there any new research that explains what creates this 550 band? Because it's a plastic deformation band, but we don't know exactly what happened in this crystal structure.
Yes. Okay. There is a very good conferences that you are invited by invitation only, the BIRS research conferences. So not for public, and we're not allowed to publish outside what is, but some things it's okay to say. So in these conferences, we sit 3 days, all PhDs, doctors, universities, discussing what is origin brown color, what's origin pink color. So it is accepted within our research community that there's a brown or pink graining, and there is some defects associated with that, clusters, like little holes. So this is they think these clusters next to the graining are responsible for the pink, brown, or brown pink, or whatever color of diamonds. And how we know it's possible? Because we did a lot of experiments. My first research for the HPHT treated diamonds. So we found these yellow-green diamonds treated, and the brown stones before, they're deformed like this. Perfect lattice is a square. So basically, with the HPT treatment, they're a little bit realigned, and when they're completely destroyed this, not destroyed, realigned this brown graining, become colorless color. And pink or brown are somehow between these two stages, like crooked to straight between a brown, pink, or pink color. So there's some truth. The reason Argyle has so many browns and also pinks, interesting, because it's the same. It all depends on how our nature play with this 0-10% to expose to more to the pressures or less. So yes, this is official theory, but still some mystery around this, yes.
Thank you very much. Unfortunately, we don't have time for more questions, but he's really easy to find out there. So if you have any more questions, just go to him and ask those technical questions. Thank you very much, Branko. It was a privilege to have a gemological.
And look at the photo of me and Rui.
Oh, okay. You stay in down. If you wish. If you wish to. Okay.
Thank you, Rui.
I thank you. This is the first speaker that asks a photo op with me. Thank you. Finally. I'm kidding.